All right, today we got a big one here. Today we're going to be graphing rational functions. A rational function is a function in the form of this right here, where we have two polynomial equations right here. I guess you can call them px and qx, and we need to assume that qx is not 0. All right, now the first section we need to do is talk about excluded values in vertical asymptotes, and we'll talk about what that looks like on our graphs. So we need to figure out what makes the denominator 0, because that's going to be a value that we cannot have in our tables when we're graphing these here. These are going to mess up the domain. So what we generally do for these here is we take the denominators, whatever the denominators are going to be, and you set them equal to 0. So x minus 4 equals 0. This means that x equals 4 right there. So what that means is that x equals 4, there's going to be a gap in the table, and we'll talk about what those gaps look like. And this is actually called a vertical asymptote when this happens. Okay, with b, kind of the same idea. You take the denominator, whatever it is, x minus 3, you set that equal to 0, and then you get x equals positive 3. So apparently there will be a gap there, or a vertical asymptote there as well. Okay, with C right here, since you have two things, you take both of your binomials. I guess x plus 2 and then x minus 5, you set those equal to 0, which really you can just set them individually equal to 0. You can say x plus 2 equals 0, which means x is equal to negative 2. And then you can do x minus 5 equals 0, which means x equals positive 5. So there are two different vertical asymptotes on that one right there. So what that does is messes up our domain values when we're looking at our graphs here. So for this next part here, they're asking for the domain. Recall that in a fraction 0, and the denominator is undefined. Therefore, the values that cause that fraction to be undefined must be excluded from the domain of the function. So state the domain of each of these functions that we had above here. So since we had an asymptote at 4, or a gap basically in our, let me move that thing. A gap at 4 right there. We're going to write our domain this way here. We write our domain values. One way you can write it is x cannot be equal to 4, but it's everything else. Another way you write it here, and this is actually how I make my students write it, is with interval notation. We'll say from negative infinity to 4, and then from 4 to infinity. And then that's it right there. Okay, for this next one here for b, I guess we're going to say from negative infinity to 3, and then from 3 to infinity. Okay. With this next one, since there's two gaps, there's kind of like three pieces here for your domain. It's from negative infinity to negative 2. That's the first one. Then it picks back up, and it starts at 2, and then it goes all the way to 5, and then it goes from 5, and then all the way to infinity. So kind of like what I was saying earlier here, you're going to have what we call asymptotes going on at those x values, and we're going to talk about what that looks like here on a graph. So I've already went here and typed these graphs in, so we'll take a look. So first of all, to graph these, you need to go to y equals, then you're going to type them in. So I already had this one here typed in. The first two are pretty easy to type in. There's nothing really too wild, just 2 divided by x minus 4. Just make sure you put around your binomials, put parentheses around those, because your calculator might miss. Might not know what you're trying to graph if you don't. Okay, so I got that first one. I just got that blue one turned on right now. So we'll hit graph, and we'll take a look. So notice at x equals 4, I guess it's kind of hard to point to it, but right here at this x value, right there for that first graph right there, that's where the graph levels off vertically. So that's why we call it a vertical asymptote right there. So that means there's no value there at 4, but then everything else has values for it. So typically they kind of look like this here. So you have a vertical asymptote, and then you'll have something to the left of that and then to the right of it, but nothing at 4. If you're wanting to look at the table, you get second graph, and then you can look at all of those different values. A lot of them will be decimals. Sometimes there's a couple of clean ones around here, so I guess those would be some nice ones to plot. So yeah, let's go ahead and copy some of that table over. So I'm going to pull my screen up here, see if I can scoot it so I can still see this table. So when I'm graphing these here, the first thing I do is I find the asymptote, and then I'll do a vertical line, going through, I guess, x equals 4. Here in a moment, we're going to talk about our horizontal asymptotes, but with this first option, or this first graph here, we had a horizontal asymptote. If we look back here at the graph, horizontal asymptote at 0. So sometimes it's a good idea to label that as well. And I know it's kind of hard to do when it's on the actual x-axis there, but get it as close as you can right there. And then we'll just copy over a couple nice points. Looks like we got 2 comma negative 1. What else we got? 3 comma negative 2. So a couple points there. Looks like we got 5 comma 2. 2, 3, 4, 5 comma 2. And then 6 comma 1 right there. And then everything else isn't really that pretty right there. And then, yeah, go ahead and sketch out the ends of your graphs right there. Just make sure you emphasize that they level off at the asymptotes. And then that usually is good enough there to get you a nice graph. Once again, if you want to write your domain, the domain was from negative infinity to 4, and then from 4 to infinity. Okay, let's look here at the second graph. So we have this one here. I'm just going to scroll to the right, hit enter, turn that graph off, and then I'm going to hit enter on this red one here, and then see what that looks like. So this one looks like it's leveling off here at positive 1 as far as horizontally, but then your vertical asymptote was happening at 3, and that was because of the denominator messing that up. So let's graph that right here at x equals 3. Just do a dotted vertical line. That's typically how I'll do those. And then it was leveling off at 1. And here in a moment, we'll talk about why. But for right now, just sketch those. Let's go back to our graph here and do second graph just to get a few table values. This one doesn't have as many nice points. It's got a few, but we can get them here. So apparently at 0, 0, that's a nice point right there. You got 2 comma negative 2. So now it looks like those are going to be the only nice points on that side. You got 4, 4, and then 6 comma 2. And then you can sketch the rest of your graph. Just make sure you level it off at your asymptotes, and then that'll be good for that. It's kind of hard here to graph it on the screen, but we'll call that good enough. Domain is the same thing here. I'm going to be lazy. Take the domain, just write it down here. Yep, there you go. All right, let's look at this last one here. So this one had 2 things that were excluded values, or 2 things that messed up the domain. And notice how I typed it in here. Of course, you got to go with parentheses, but the way I typed it in here, you need to have a set of parentheses. Actually, I need one more set here. So for this whole denominator, to get x plus 2 and x minus 5 in the entire denominator in your calculator, I put an extra set of parentheses there because we're dividing by that whole thing. And then I guess I'm going to put an extra close parentheses right there. And then that graph should look good once we hit graph. So make sure you graph it like that. So this one's got 2 of the asymptotes. Now it kind of looks like it doesn't go up forever. The calculators, for whatever reason, don't draw vertical lines very well, but it should be going up forever. So you have 2 asymptotes there. So we'll see if there's any nice points. I guess if you want to go ahead and graph a few things here, we can graph the asymptotes. So I'm going to go ahead and do that. The asymptotes were at, I believe, what was that? Negative 2 and then positive 5. So I'm just going to do dotted line at negative 2 vertically, and then also at positive 5, and then vertically. And then it was leveling off at 0 horizontally. So really, if you have those sections, most teachers will give you credit if you just have the right shape. We're going to see if we got any nice even points right here. So let me pull this side, second graph. There we go. Now want to work with me there. So we got a few, it looks like here. Keep scrolling. Yeah, we're not going to have much here, so I'll guess I'll get that -3 comma -2.5. I'll get that as close as I can. And then what was it? Oh, it was a -0.25, so it's down here below. So for this the left side of the graph, you really can't graph much. So we're just going to graph it like that right there. I guess we got a point there. We got at -1, 0. And I guess we could go like 2 and -2.5. So something kind of like that right there. Let's see if this will let me draw. Make it go down like that. Really, once again, we're looking for the shape and then just making sure it is in the correct regions. And then this last one here, I guess it was at 5, the last asymptote. Yep, so it was at 5. And I guess we could probably go 8, 0.3. That's probably close enough. So 8, 0.3, kind of like close right there. And then sketch a graph. And then that would be good right there. And that would be what we're looking for there on that. So just make sure you draw them where they're leveling off at the asymptotes, and then I think that'll be good enough there on that. So there you go on that. Let's see what we got next here on the next page. Points of discontinuity. Sometimes in a restriction on the domain or on the denominator results in a point of discontinuity, and basically it looks like a hole in a graph. In the graph, instead of an additional or instead of or in addition to a vertical asymptote. So graph the function below on a calculator. Given its domain, be prepared to discuss what effect the domain has on the graph. So if you look here at the bottom, something weird's going on at x minus 5 equals 0, which means something weird's going on at x equals 5. So a lot of us want to say, oh, that means that there's an asymptote at x equals 5. But because of the numerator, since the numerator here factors as x minus 5 and then x plus 5, we can say that the x minus 5 in the denominator cancels out. So this graph is going to look like the graph of x plus 5. There's just something weird going on here because the denominator here. So we're going to say it looks like x plus 5, but x cannot equal positive 5 right here. We'll see what that looks like here in a graph. So close this out here. I forgot we needed to do this one here. So I guess I'll clear that one out. And I'll just type it in the exact way it looked at the beginning here. Okay, so after you get that typed in correctly there, we'll look at the graph. And notice that does look like the line x plus 5. And really, we don't see anything that's weird about this graph here. We don't even see this mysterious hole that we were talking about. But if we look here at the table, it actually has an error at 5. And that was because of that point of discontinuity. And it's kind of hard to actually get it to show up on a graphing calculator. But I guess when we go and graph these here, we want to sketch it kind of like this right here. We'll start, up here at 5 on your x-axis here. And then we're going to draw a graph. And then at 5, wherever that is on the graph, we'll put a little open dot right there. And that's your point of discontinuity right there. And that's kind of what this graph here looks like right there. As far as your domain, you still write the domain the same. You say from 5, negative infinity to 5, and then from 5 to infinity. But the graph just looks a little bit different here. And with these, make sure you sketch a hole, and then you'd be good to go. And that's what those look like. Okay, they got a little piece here on the vertical asymptotes, and then I guess the point and discontinuities. So typically, when we're graphing these here, we want to factor the denominator and find its zeros. There will be a vertical asymptote for every 0 in the denominator that is not also, I guess, a point of discontinuity. And then also, if it's not a 0, I guess, of the numerator is what they're saying. For points of discontinuity, yeah, we just got to look at it. Here's kind of what we're talking about here. Let's use this example here. So, like, since there's an x minus 3 in the top and bottom, that is what's going to mess up right there. And that means there's a point of discontinuity at x equals positive 3. And that's because it's the opposite side, right? So we have x plus 2 equals 0, x equals negative 2, and then we have x minus 3 equals 0. That means x equals positive 3. So at x equals negative 2, since nothing cancels out the x plus 2 right there, this is a vertical asymptote. And then at x equals 3, since those could cancel out, we call this a point of discontinuity. And that's the difference between them right there. So point of discontinuity is at x equals 3. The vertical asymptote is at x equals negative 2. And that's really what we're trying to get in your head. Now, a lot of the times, you're actually going to get these where they're not factored, and we have to factor them ourselves. So like this numerator here, if we're going to factor that, need something that multiplies to x squared in the front, x and x, and then something that multiplies to negative 3 here in the back, but then adds up to 2. So I guess we'll go x, was that plus 3, and then minus 1 right there. Should get that right there. And then in the denominator, same idea. 2 binomials. We'll go x, I guess, plus 2, and then x minus 1. Okay, so look at where the denominators equal 0. X plus 2 equals 0, so x is negative 2. And then x minus 1 equals 0, so x equals positive 1. So since nothing cancels out this x plus 2 in the denominator, this is truly a vertical asymptote. All right, and the point of discontinuity is this other one, and that's because the x minus 1 factors would cancel each other out. Right there, so we'll say vertical asymptote at x equals negative 2, point of discontinuity at x equals 1. And then that is it there on those. And that's how you can get that stuff without a graphing calculator. Okay, next page here, we're going to talk here about horizontal asymptotes. To determine what the horizontal asymptote is here, we look here if the degree of the numerator is less than the degree of the denominator. If you forgot that, that's less than. So if the degree of the numerator is less than the degree of the denominator, well, when we call this a bottom heavy case, then the horizontal asymptote will always be the line y equals 0. Okay, so like for example, that'd be something like this here. The degree of the denominator is 1. The degree of the numerator is 0. You don't have like x raised to anything right there. So since this one right here is bottom heavy with the powers, we're going to say the horizontal asymptote, usually I'll use HA for that, is going to be at y equals 0 every time. Okay, and that's only on those bottom heavy cases. Okay, if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote will be the ratio of the leading coefficients. You're going to figure out the leading coefficient in the numerator and the denominator, and it's a ratio of those. For example, with example B, you got degree 1, degree 1. So whatever the leading coefficients are, they're both 1 here. You're going to say the horizontal asymptote is at y equals 1 over 1, which obviously is 1. So the graph will level off there. Okay, and then you say if the degree of the numerator is greater than the degree of the denominator, if it's top heavy, then there is no horizontal asymptote. And actually, you'll probably get into it with pre-cal. You might even touch on it in pre-AP algebra 2. But it's essentially kind of like a diagonal asymptote. But so since this one here, this is x to the first, and then we have x times x. Eventually, this will be x squared. I guess minus 3x, and then minus 10 once we FOIL it together. Your degree in the denominator, actually your degree in the denominator here is actually 2. So actually this one's y equals 0. I thought this was going to be a different example here. So yeah, there's your horizontal asymptote. So anyways, kind of lost my train of thought there. But anyways, if it's ever top heavy, you're just going to say it doesn't have a horizontal asymptote for right now. So just look at your powers. Typically the ones we'll give you will either be bottom heavy, or maybe they'll be the same degree but then different leading coefficients that you need to do the ratio of. Okay, zeros of a function, the zeros of a rational function, the x-intercepts are found by finding the zeros of the numerator. Yeah, so basically set your numerator equal to 0, and you'll be able to find your x-intercepts. And we'll show you that here in a second. Your y-intercepts, if you plug in 0 for x, you can find those right there. Those are going to be pretty straightforward. And I think we're going to do that here in just a second. So, all right, graphing rational functions. So basically all that list of stuff that we're kind of talking about here, we're going to go and actually graph with these, and we're going to try them without a calculator. So usually you want your vertical asymptotes, your horizontal asymptotes, if there are any, and then find your zeros, your x-intercepts, your y-intercepts, and then we'll do the domain and range. So it's a lot of stuff. It seems overwhelming at first. Once you get in a routine of it, though, it's not bad. Okay, 4 vertical asymptotes every single time on these here. Basically, you need the set denominator equal to 0. I'm just going to kind of make quick little notes here. So for this one here, we'll go x plus 1 equals 0. That gives us x equals -1. So that means a vertical asymptote at -1. So we're going to go ahead and sketch that. Usually that's where I start with my graphs. They're my vertical asymptotes. Horizontal asymptotes, you got to ask yourself, bottom heavy, okay, so top or bottom heavy, or if they're the same, it's a ratio here. With this one here, it's bottom heavy. That's because your power, your degree is 1 right there. So anytime that happens, horizontal asymptote's always at y equals 0. I guess I'll go back to the same color here. So just do a horizontal asymptote right there is 0. That's where it should level off. Okay, for x-intercept here. For your x-intercept, you're always going to set your, really, you set your left side equal to 0. Set y equal to 0. But if you think about this here, if you cross multiply this, or if you just multiply both sides by x plus 1, you get 0 equals 3, which means that cannot happen there. So that means there's no x-intercept in this case. And also, if you think about it here, we have a horizontal asymptote at y equals 0. It should never cross the x-axis. Okay, y-intercept, all you're going to do is plug in 0 for x for your y-intercept. So let's see here, that'd be 3, and then over 0 plus 1 right there, that's going to come out to positive 3. We'll write these always as an order pair, 0, 3 for your y-intercept. So actually, let's go ahead and plot that. 0, 3, that would be right up there. Okay. And then domain. Domain is basically everything but your vertical asymptote. So we're going to say from -infinity to -1, and then from -1 to positive infinity. Okay, and then range, pretty much the same idea, except you look at your horizontal asymptotes. So we're going to say from -infinity to 0, and then from 0 to infinity. Okay, and then from there, there's a couple of different things you can do here, depending on how detailed your teachers want you to be. If you need specific points to plot, I guess, think of numbers that you can plug in here. You could like make yourself a little table here, and then think about numbers that if you plug it in, you'll get like nice whole numbers or something like that. So like, for example, we already got 3, or we have 0, 3. That came out real nice. If I plug in 2 in the denominator, that should come out real good. That'll be 3 and then plus or 3 over 3, essentially. So that should come out good. You can also do some on the negative side. So I guess if we went and did like a, let me think here, like a -2, I believe, here in this case, that would get us 3 and then over basically -1. So that's going to be -3. And then I guess we could do something like, Yeah, if we did like a -4 or something like that right there, you could go 3 and then -4 will get you -3 in the denominator. So that'd be -1 once you reduce right there. So, just making a table there. Most of the times, honestly, if you have your y-intercept up here, most of the times you can just sketch graphs, kind of like this right here. But if you want to get real precise, you probably need to make a table. So anyways, I'll probably do that on the other examples to speed it up here. But let's graph the points we at least have here. So 2, 1, there's a point. -2, -3 down here. -3, -1. Kind of like that right there. And then that should be your graph right there. Sketch and make sure you don't go past your asymptotes, and then you'll be good. And then, yeah, there you go. There's your graphs on these here. And that's all without a calculator. So we'll speed it up here through the last few here that are just like this here. So vertical asymptote wins the denominator equal to 0. So that's actually at 0. Okay. Horizontal asymptote, you got to ask yourself, top heavy, bottom heavy are the same. The degree of the denominator is bigger, so we're going to say that's at y equals 0. Okay, x-intercept, you can plug in 0 for that left-hand side. Really, you can just set 0 equal to the numerator, because when you multiply, your denominator is going to cancel out. So 0 does not equal 2. That can't ever happen. That means there is no x-intercept. Here's the weird thing with this one, y-intercept. If I go plug in 2 divided by 0, you can't do that in your calculator. Like your calculator is going to give you an error, so that means there's no y-intercept on this one. Okay, domain and range, you can just say from -infinity to, 0, and then from 0 to infinity, and then the same exact thing for range. And remember, these are tied into your asymptotes. Those are always tied into your asymptotes. And then I guess we can go and plot some points here. We need to graph our asymptotes. Obviously, it's kind of hard to graph when it's on the axes, but just make sure your graph doesn't go past those there. Now, if we wanted some nice points, I'm just going to quickly make a table here. I'm thinking of numbers for x that I can divide by 2 pretty easy. So obviously you can't have anything going on at 0, but if we plug in 2 divided by 2 would be 1. I guess if you plugged in 4, I guess you could get like 1/2. We could plug in -2 actually and do -1. -4, I guess will get you -1/2. There's a couple nice points. So let's see, 2, what was it? 2, 1, 4, half. There you go. And then the other graph, the other side, -2, -1, -4, half. Guess we could have done -1 pretty easy. -1 and +1. But yeah, there's your graph right there. So once you do it a few times, they speed up. See if we can find one here with a little bit more interesting horizontal asymptote and that type of stuff, and x and y intercepts. This one's actually a pretty good one here. I like it. With this one, vertical asymptote, set x minus 3, the denominator, equal to 0. You're going to have an asymptote at x equals 3. Horizontal asymptote, so since the degrees are the same, it's always going to be the ratio of the leading coefficients. The leading coefficient of the denominator is 1, so you're going to do the fraction 2 over 1, which obviously is 2. All right, x-intercept. So with the x-intercept, we set the left side equal to 0. If you multiply both sides by x minus 3 to cancel out the denominator, really that's just going to be 0 equals 2x plus 1 right there. Really just set your numerator equal to 0. And then we'll subtract 1 and then divide by 2. X is going to be -1/2. So we'll write that as the order pair -1/2, 0. You can actually go and plot that here in a second. Y-intercept, you're going to just plug in 0 for your x. So This is for the x-intercept, and then the y-intercept will go 0. Oh yeah, 0 for x. So this will be 2 times 0, and then plus 1, and then divided by 0 minus 3. Yes, ma'am.
Jacob's test.
Oh,
Looks like
okay.
he left a couple blanks.
Oh, okay.
And then that's
Oh, you found one.
Yeah.
All right, cool. Thank you. All right, and then once you simplify, you're going to get the fraction 1/3 here. And actually, it'll be negative 1/3 here. And we'll write that as 0, negative 1/3. And then your domain and range, that's tied to your vertical and horizontal asymptotes. Domain is from negative infinity to 3, and then from 3 to infinity. And then your range is from negative infinity to 2, and then from 2 to infinity. And then we'll go and plot all that stuff there. Vertical asymptote was at 3. Go ahead and give me a dotted line at 3. Okay, horizontal asymptote's at 2. Okay, x-intercept was at negative half 0. So that would be actually way over here. Y-intercept is going to be at 0, negative 1/3. So kind of like right there. And then I don't know if I doubt there's going to be any really nice points here for this. So since we have kind of points in this bottom left of our asymptotes spot right here, I'm just going to try and sketch my graph going through that right there. And then this other piece is going to be kind of like this right here. I don't think, there might be a few nice points there, but most of the times if you just get your graph level off there, you'll be okay. Or you just use your graphing calculator. Okay. Next one here. Now this one here, you have x plus 3 twice right here. So that's kind of a weird one there. So that might make the graph actually look a little bit different here. Now as far as when is the denominator equal to 0, it still kind of works the same here. So you can, I guess, square root both sides, which is square root of 0 is 0, and then subtract 3. So this is x equals negative 3. Okay. Horizontal asymptote, so its power is 1 here, but when you FOIL it together, it's going to be degree 2. That's definitely bottom heavy. So it means horizontal asymptote will be at 0. And then x-intercept, we're going to plug in, we're going to set the numerator equal to 0, which cannot happen there. So we say that there is none here. And that's because of your horizontal asymptote. Y-intercept, we're going to plug in 0 for x. And then I guess we're going to square that right there. That'll get us our y-intercept. That's basically 2 over 3 squared, or 2 over 9. So that's not a very pretty number there, but that's okay. Domain, use your vertical asymptote. Negative infinity to negative 3. And then negative 3 to infinity. Horizontal asymptote helps us with the range. Range is negative infinity to 0, and then from 0 to infinity. And then where we have negative 3. There we go. Now I already got the points pulled up here from the table here. So what's kind of weird about this graph here, if you go and make a table, I guess, and then plug in some of the points here, if you go plug in negative 2 in for x, you actually get positive 2, which is going to be right there. But then if you go plug in negative 4, and this is what kind of makes this weird here, you actually get positive 2 as well. So it's over here. So the graph actually kind of looks like this when you go and put it in your graphing calculator. it levels off on both sides, but it kind of comes up to a little point up there in the middle. So the graph actually doesn't go below the x-axis at all on this one. So that's kind of what makes this one a little bit different. So just kind of be on the lookout there for that. So it's not always going to be in opposite corners. Really, you need to like go at least find one point on the left side and then one point on the right side if you're going to do that there. So yeah, that's that there. So all right, let's talk about 5. What makes 5 different here is it's not factored in the bottom. So we need to always have these factored to be able to work with them here. So always, always, always factor if it's not already. So we'll call this, I guess, x. I think this will be minus, minus 3, and then x, I guess, plus 2 on this one. Okay. And then, so with this one here, I guess what's significant about this one here is the x plus 2. These are going to actually cancel each other out here. So then this is just like 1 and then over x minus 3. But then you have a point of discontinuity. That point of discontinuity this time is at x equals 3. The actual asymptote for this graph here is going to be at, or I'm sorry, here I said the wrong thing. The point of discontinuity is actually at x equals -2. The vertical asymptote is at x equals positive 3. That's just because it's set in your denominators equal to 0. Since the degree is bottom heavy, we're going to say that the horizontal asymptote is 0 again. I hadn't seen a ton of examples where it's not been. The x-intercept, for the x-intercept, set x plus 2, the numerator, equal to 0. Right up there. So that gets us x equals -2. That'll be at -2 comma 0. For your y-intercept, plug in 0 for x. I'm going to plug it into the factored form right here. So that would be 0 plus 2, and then over 0 minus 3, and then 0 plus 2. All right, which is basically going to be 2 over -6. That's going to come out to 1/3, or -1/3. So we'll say that that is 0 comma -1/3. And then domain and range from -infinity to 3. And then since there's that point of discontinuity, we got to go, actually, yeah, hang on, I wrote this wrong. We're going to go from 0 to -2. You want to do that first number. From -2 to 3 for the next set, and then from 3 to infinity. And that's because you have the point of discontinuity right there, in that gap, or actually, I'm sorry, right here in this gap, and then you have the vertical asymptote in this second gap right there. So the domain's pretty wonky there. And then the range that's tied into your horizontal asymptote, that's just going to be from -infinity to 0, and then from 0 to infinity. Okay, and then from here we'll go and start to sketch some of the stuff that we can. Vertical asymptotes at x equals 3. Horizontal asymptotes at 0. Now the discontinuity, the point of discontinuity is at -2, but we don't exactly know where. Like it could be like way down here, it could be up there. So we're just going to kind of follow our graph here in just a second to get those points. And then let's see here, we need to get our x and y intercepts plotted here. 0, -3, or I'm sorry, 0, -1/3, kind of like right there. And then x-intercept, or what was that? Oh, yep, at -2, 0. With this one here, this one's kind of a special case here. First of all, we got to factor anytime it's not factor. So we're going to write this as x, I guess let's do +2 and then x minus 3 there. Okay. Now, as far as your vertical asymptote, you got to be careful because you're going to have a point of discontinuity right there. When you set x plus 2 equal to 0. So that means there's a point of discontinuity at x equals -2. So the vertical asymptote's the other one that doesn't cancel out here. So that's going to be at x equals +3 when you do that. So when you simplify the function here, it's going to be like this right here. 1 over x minus 3. And you have to simplify it to find one of these points here in a second. So we're going to start using this here from now on here. Horizontal asymptote, if you look here, it's bottom heavy on the power, so you got degree 1. So once again, it's y equals 0. Hadn't seen a ton of examples where it's the even powers with each other, but are the same powers, I guess. Now the x-intercept, you got to be kind of careful here on this. If you think about it, if you have a horizontal asymptote at 0, that means there should be no x-intercept. Now you got to be careful. Some people are going to want to set your numerator equal to 0, but then don't forget we had a point of discontinuity at -2, so that's going to mess that up here. So really what I want you guys to do when you're finding your x-intercepts is use the simplified form. Okay, and if you go 1 equals 0 or the numerator equals 0 right there, that's what's going to mess you up here. And then we're going to say that there is none. No x-intercept, I guess. Okay, y-intercept, that's going to be plug in 0 for your x value. So we can go 1 over 0 minus 3. It's going to come out to -1/3. And then we'll write that as 0, -1/3. Your domain, that's tied to your vertical asymptote and your point of discontinuity. So you're going to have two gaps here. This is going to be from -infinity. Go up to the first, whatever comes first, the point of discontinuity or the asymptote. So we'll go from 0 to -2. And then we're going to go from -2 to the asymptote to 3, and then from 3 to infinity. So there's two different gaps. Okay, your range ties to your horizontal asymptote. That'll be from -infinity to 0, and then from 0 to infinity. And there you go. Now, as far as graphing some of this, the asymptote, obviously, those aren't too bad to graph right there. Vertical line there, horizontal line at 0. The point of discontinuity, you got to be careful with the x. That's happening at -2. But if we're thinking about this, like we might have a gap right there. It might be way down here. I'm not sure. So I'm going to hold off on graphing that real quick. And then I guess we can plot our x and y intercepts. We didn't have an x-intercept. The y-intercept was at 0, -1/3. Okay. And then as far as some other, I guess, nice points that we could use, I think we're going to have something here at 4. I think we have my notes here say 4, 1. Also, if we have something at 2, I think we're going to have 2, -1 right there. So there's a couple of points there to get our graph. So here's what I want you guys to do. Draw your line, put a gap at -2. That's where your point of discontinuity is. So just put a big old open dot right there. And then that's how you graph these right here. And then make sure you level off at your asymptotes there. And then you're good to go. So just think of, make a table if it helps you. Get a couple of extra nice points. I used 4. And I got 1, and then I used 2, and then I also got 1 right there. And that helped me get the shape and which sections they're supposed to be in. Okay, awesome. All right, last thing here that we're going to just talk about here is just graphing transformations. They all kind of work how you would expect here. So here's a typical thing right here. -h, that moves you left and right, just kind of like how it has in before. K is up and down. A is a vertical stretch or shrink. So just graph this right here, state the domain and range. So this -1 here, this is going to move our asymptote to the right one. And then the +2 is going to shift everything up 2 units right here. So normally the horizontal asymptote's at 0. But since we got that +2, that's going to move everything up. And then state the domain and range here. So honestly, you probably have a calculator on something like this here. So I'm going to go off to the side and type it into the graphing calculator. I guess I'll delete this one here. So we'll go 3 divided by, since we're doing a binomial in the denominator, put x -1 with parentheses. And then just +2 outside of the parentheses should be good. And your calculator is going to know to divide it first and then add 2 to that. And then let me go turn my other ones off. All right. And then hit graph. There you go. So there's your asymptote there at 2. and then it looks like a vertical asymptote at 1. And then we'll hit second graph to get a couple points from the table. So horizontal asymptote at 2, vertical at 1, and then copy over a couple points and then get the domain and range. So let me see here with the graph. I don't think, oh, okay, yeah, there we go. -2, comma 1 was a nice point. I guess -1 and then half is pretty decent. You got 2, 5. Oh wait, 0, -1 actually. We can do that pretty good. Yep, 2, 5. There's a point. 4, 3. Another decent point, and then I would just sketch the rest. Sorry, I know this doesn't look pretty here on the iPad, but kind of hard to get it perfect. And there's your graph. Nice and easy there. Normally, too, if they're talking about transformations, you would describe the transformations usually on these problems. So we could say this graph moves left 1 and then up 2. And then I guess you could say that the 3 is a vertical stretch. All right, this is the graph. This graph's a function that is a translation of this one here. What is the equation? So I guess we just got to figure out where the horizontal and vertical asymptote are moving. So it looks like your horizontal asymptote moved down a couple of units here. Normally it's at 0. It looked like it moved 2. And be careful here. I guess each tick here is 2, so that looks like at -4. So we'll say y equals -4. Yeah, so that moved us down 4. So I need a -4 outside of the fraction. And then as far as left and right, it looked like it went right only 1 unit. So we'll go x minus 1 inside, or I guess in the denominator right there. And then there would be your function right there. And I believe that it'll be it here for today.